figure out the slope of this graph, what do I need to do? What do I need to do?
You need to find out the constant rate of change.
Yeah, constant rate of change. So we've learned a couple of strategies to do this. So can anyone remind me what's one of the two strategies I can use?
Rise and fall.
Rise over run. And what's the other strategy? Remember, we've been doing this for a couple of days now. Rate of change. What can I use to find the rate of change? Nobody? I'm going to sit here and wait because I'm not the one taking a quiz on this. You guys are.
Rate of change formula?
Yeah. What's my rate of change formula?
y2 minus y1 over x2 minus x1.
Yeah, that's it. Okay, and we've been doing this all week, so this is not anything new. So I could use whichever of those two I feel like using. Some people prefer one, some people prefer the other, that's fine. But no matter which one you decide on, the first thing you gotta do is find 2 points from the graph that you can use. Now remember, you want them to be perfect points. So you don't want them to be floating somewhere in the middle. So on this graph, can anybody give me a perfect point?
10 and 1500.
Very good. 10, 1500. And I need 2 of those. So does anyone see another one?
0, 4,500.
Good. 0, 4,500. All right. So again, I could use one strategy or the other. I'm going to show both ways, but at the end of the day, you get to choose which one you prefer. Okay? So I'm going to start with rise over run. With rise over run, you got to connect the 2 dots, going straight up and straight down, and then straight to the right or straight to the left. So we're making a triangle. Now, what is the measure, like how long is the line going down? You have to look carefully and look at the units. How many units is that line? How many units, guys? We're counting.
Is it 5?
5. Okay, so, oh, hold on. Someone's coming into the meeting. Okay. So when you're counting, be very careful because each unit isn't equal to 1. How much is each unit worth?
500.
500, exactly. So if each unit is 500, count again. How many is it total?
3,000?
Yeah, 3,000. Because if I count going down, I get 500, 1,000, 1,500, 2,000, 2,500, 3,000. And since I'm going downwards, what am I going to pop in front of that 3,000?
Negative.
Negative. So this is negative 3,000. All right, and then what about going across? How many units does it go across?
0.
5.
Remember, count the units. How many is each box worth when you go across?
Oh, 2.
2. So how many is it total?
10.
10.
10. 2, 4, 6, 8, 10. So that's the hard part. Rise over run might seem easy, but if your units are big numbers like here, it's going to be harder to calculate. So you really have to pay very close attention to all of those things. Okay, so M equals rise over run. So which one of those is my rise?
Does it matter?
It
The
does.
10?
It's not going to be the 10.
Negative 3,000.
It's negative 3,000. Because if you think about it, rise, the words rise and run kind of tell you where to look. Rise tells you to look up and down. Run tells you to look across, because when you run, you have to run across a
Okay.
straight line.
Okay.
Okay, so it's negative 3,000 over 10, which means my final answer, when I divide, what's negative 3,000 divided by 10?
Negative 300.
Negative 300. What are my units?
Meters per minute.
Yeah, meters per minute. Meters per minute. And remember, your slope always tells you the speed, how fast, whatever you're measuring, it's telling you how fast it's going. So here, it's telling me that the tram or the truck or whatever it is, the train, is going at a speed of 300 meters per minute. Okay, so slope is always speed. Now, I'm going to do the same thing, just using my formula instead. Because again, some people are more visual, some people are more mathematical. So instead of doing rise over run, I'm going to use the formula and I'm going to get the same answer. Now, before I plug everything in, I'm going to organize my 2 points into a table. So I have 0, 4,500, and I have 10, 1,500.
I like that one better actually.
I like it better too. I like it better because to me, when I see the numbers, it makes more sense in my head. All right, so I'm plugging it in. Y2 minus Y1, what is that? What numbers am I using here?
1,500.
1,500 minus,
4,500.
4,500.
yep. And then I have 10 minus 0. So on the top, what do I get?
Negative 3,000.
Negative 3,000. And then on the bottom,
10.
10. So notice we got negative 3,000 over 10. What do you guys notice about that?
It's the same as the rise over run.
Same exact numbers as from your rise and run. Same numbers. You're doing the same thing. It's just that one way to do it is more visual and the other way to do it is more mathematic. You're doing the same exact operation. So we still get the same answer. Negative
For
30.
the for the second one, I was a little bit confused about how you put the 1,500 first.
Okay, good question. So when I made my table, I like organizing things in a table because it just makes it easier to see and understand. Remember that with your table, the first point would be x1 and x2. And the second point would be not x1 and x2, sorry. x1 and y1. There we go. And then the second point would be x2 and y2. Simply because the top point is number 1 and the bottom point is number 2.
So pretty much from Y. So what you did for the top is like 4,500. That's Y1.
Yeah,
Okay.
exactly. Okay. All right, so it seems like those of you who are in school, there's something going on. So I need to figure out what's happening here. So you guys are in a different classroom with somebody who's teaching another class. Great. So if you're in school, use your headphones if you have them. Okay, if you're in school, use your headphones if you have them. I'm going to figure out if there's a way for us to solve the problem. But everybody at home, keep following along. All right, so I've shown you guys how you get the same answer no matter which strategy. So when it comes time, if it's asking you for the slope, you get to choose whichever strategy you prefer. Now, y-intercept. What is the y-intercept of this linear function?
4,500
4,500. And where did you look for that?
at the first point on the x-axis.
Yeah, exactly. The very first point. Notice it's also where whenever x is 0, that's your y-intercept. So that's another way to think about it. Wherever x is 0, that's going to be your y-intercept. So my y-intercept is 4,500. And what are the units on that?
Meters.
Distance.
Distance in meters, exactly. And how can you summarize what that number means in this scenario? So it looks like I didn't copy down the word from this problem, but it's a tramway, so it's like a little train that's trying to get to the peak of a mountain. So what is this 4,500? What does that mean?
And
The top of the
4,500
peak.
and 4,500 meters. It took 15 minutes to get to 4,500 meters.
So it took 15 minutes. So we know that the x-intercept tells us how long it took to travel all that distance. But I'm not talking about the end. The 4,500 is the distance at what point in his journey?
The beginning.
The beginning. So 4,500 meters, yeah, is the starting distance. It's where it begins. So to summarize everything that we've kind of touched upon so far, the rate of change, the slope, is the speed that it's traveling at. So it's how fast it's going. The y-intercept is where it begins. And in 99% of the problems you guys will see in this class, that's always going to be true. It's always going to be that the slope is the speed and the y-intercept is the starting point, no matter what you're talking about. Okay, so today we're going to be talking about these two things all over and over again. We're going to talk about slope and we're going to talk about y-intercept because it turns out that they're two very, very important things. So let's go ahead and take a look at a different type of graph, but we're going to do the same thing. In this graph, again, we're going to look for the slope and we're going to look for the y-intercept. Now, I want you guys to try it on your own, but before you begin, let's make sure we have two perfect points to look at. So right now, where can I find some perfect points?
Miss on the left in the top.
Okay, be more specific. What is the actual number there? What's the coordinate point?
-4, 6.
-4, 6. Very good. -4, 6. That's one perfect point. Is there another one somewhere?
-4, 0, -4.
Good. 0, -4. Okay. So I want you guys to figure out what is the slope. Calculate the slope using whichever strategy you prefer. You can do rise over run, or you can use the slope formula. Up to you. But go ahead and take 2 minutes to calculate the slope. 1 minute left. You can send me an answer and I'll tell you if you got it right. All right, that's time. Let's check this out. Would you guys like me to use the formula or should I do rise over run?
The formula.
Formula?
Formula.
Formula?
Formula.
Formula? Okay, formula wins. Let's do the formula. So it's y2 minus y1 over x2 minus x1. So I have these 2 points. I labeled them on my graph. I'm going to put them in a table. Because again, a table is just better visualization. It's easier to see it that way. So I have -4 comma 6 and then 0 comma -4. Okay, now that I have my table, which one is my y2?
-4.
Y1?
6.
6. X2?
0.
And x1.
-4.
Good. Okay, I'm using those values straight into the formula. So here we go. I have -4 minus 6 over 0 minus -4. All I did was plug everything in. Now, what does that double negative do in the bottom? What happens there?
Add.
Turns into addition. So it's -4 minus 6 over 0 plus 4. Now I simplify. What is -4 minus 6?
10.
10? -4 minus 6. -4 minus 6.
-10.
-10. And then 0 plus 4 gives me
4.
4. So now I see if I can simplify this. Can I simplify this fraction? -10 over 4?
Miss, so you see, do you make it into like a mixed fraction?
Nope, not into a
Like a
mixed
decimal.
fraction. Keep it as an improper fraction, but let's simplify it because I can simplify the numerator and the denominator. What can I simplify that into?
-5 over 2.
There you go, -5 over 2. That's my slope. -5 over 2. So that was the slope using the slope formula. I'm going to very quickly do the same thing using rise over run. So watch carefully. To connect my 2 points, I'm going to go to the right, and then I'm going to go down. How much is each box worth? How many units is each box
2.
worth? 2. Exactly. It's going by 2s, so each box is worth 2 units. So when I count my run, I count by 2s, what do I get? How many units is it going across?
4.
4 units across. Counting by 2s, how many units is it going down?
10.
10 units down, so that's going to be -10. Rise over run would mean that I have -10 over 4. So notice I get the same exact answer. I get -5 over 2. Whichever strategy you want to do, it'll still give you the same answer. Sometimes rise over run is easier than using the formula. Sometimes the formula is easier than rise over run. So in this case, which one do you think was an easier strategy? Rise over run or the formula?
Rise over run.
Rise over run. Here, let's do a quick little poll. So under participants, when you click on participants, give me a check mark if you think rise over run was easier. Give me a check mark if you prefer rise over run. One check mark. One sort of check mark. Okay, give me a check mark if you prefer the formula. 3 check marks. I only have 3 students in this class? What's going on? I thought I had about 26. 4 check marks. I only have 4 students in this whole entire period? What's going on? Okay. Still only 4 people participating. I don't know what's going on, y'all. I'm tired. I know you're tired too. But I still have to show up to work. So you still have to show up and be a student. Okay, so my slope is -5/2. Any final questions on how to calculate slope and how to figure out slope? Okay, so next up, now I need to identify the y-intercept. So I'm going to erase everything I have here just to clarify, clear the page, make it nice and neat. On this graph, what is my y-intercept?
Miss, where did the... I don't know.
What does the y-intercept mean? I'm looking at where?
I don't know what it...
Where on this graph? Think about it. What does the word y-intercept say? Where am I looking?
The Y.
The y, okay. So look on the y, what do you see?
Eight?
You said 8?
Yeah.
This is 8. Is there anything going on there?
No.
No, there's nothing going on at the 8. Keep looking. I see some private answers. Let's make those answers public so you can share it with the class.
-4.
-4. Oh, what's going on the -4? What's this point? If I label that point, what's the coordinates?
0, -4.
0, -4. Again, guys, y-intercept is so easy. This is not a hard
Miss, but
thing to
why?
do.
Why there?
Because that's the place where my line, my pink line, what's it doing at the -4?
Oh, because... Oh, okay.
What's it doing?
It touches the line.
Touches the what line? Be more specific.
The Y.
The y-axis.
Yeah.
So the y-intercept is the place where your line is crossing or touching the y-axis. So my y-intercept is -4. Now, it's the same thing as this problem over here. It's just that in this graph, it's not crossing the y-axis, it stops at the y-axis. So it's on the y-axis. But it's the same idea. Even though here it's crossing straight through it, it's still touching it, and that's what we're looking for. We're looking for the place where it's touching the y-axis. So we have a variable that we're going to use for y-intercept, and the variable is b. And I'll explain why in just a second, but for now, b, we know it's b equals -4. So the slope was -5/2, y-intercept was -4. Do I have questions? And those of you who are at school, if you're listening to me, I don't know if it's working. I'm trying to see if you can get a different teacher in the room, but I don't think you can. So if you have your headphones in and you're listening to me, I still expect you to participate by writing things in the chat. Okay, even if you can't answer out loud, I still expect you to participate. I have 26 students, and it's been a conversation between me and Ilse for about 15 minutes. That's not acceptable. I need more participation. I know it's Wednesday. I know it's gloomy outside and it's been a long week. I'm tired too. Trust me, I'm tired right now. But I still need y'all to participate. Okay? So let's check out another. Okay, so on this slide, I have, let me actually preface this. Okay, let me go back. Whenever you have an equation of a line, so this linear function, let's go back to what we know about functions. We know that functions can be equations, graphs, tables. We can represent them in a lot of different ways. Okay, you can make a graph of a function like we have here. We've seen tables of values, just like an X and Y chart. That's also going to be a way to represent a function. But at the end of the day, the more mathematical way to represent a function is by using an equation. So whenever you have a line, we can write an equation for that line using what's called slope-intercept form. So just like everything in this class, you guys always know I got you. I'm going to explain everything fully. But for right now, I just want you guys to write down this definition, okay? So slope-intercept form is y equals mx plus b, where m represents the slope and b represents the y-intercept. So go ahead, take about 30 seconds to write this down. Okay, a couple more seconds. Y equals mx plus b. M is the slope, and b is the y-intercept. All right, I'm going to move on, but I'm going to rewrite this on the next slide, so don't stress if you didn't finish. So again, you have y equals mx plus b. Okay, so like I said, everything will make sense in just a moment, but for now, this is the same exact graph that we looked at 2 slides ago. And when we were looking at it, we figured out that the slope was -5/2 and the y-intercept was -4. So I'm just going to rewrite that over here. I'm not doing anything new. I'm just rewriting what I had in the previous slide. So my slope is -5/2 and my y-intercept is -4. Okay. Since I know this, since I've figured out my slope and I figured out my y-intercept, I can use those two numbers and fill in the blanks. Since my equation is y equals mx plus b, I can plug in the m and I can plug in the b. Okay, so all I'm doing so far is I just plugged in those two numbers straight in. I'm just filling in the blank. And now what I'm going to quickly do is just simplify it a little bit, because when you add a negative number, that's the same thing as just subtracting. So if I'm adding -4, that's the same thing as just -4. So I'm going to rewrite it, and this is going to be my final equation. Y equals -5/2x minus 4. Okay, so all I'm doing is filling in the blanks with the slope and the y-intercept. Do I have any questions on that so far? Awesome. Okay, now you might be wondering, okay, why do I care about this? Why do I want to write an equation? Why does that even matter? Why did I do this, right? Well, the reason that an equation is really, really useful to us is that equations can help us find values that we can't see with our eyes. So for example, remember how I was talking about how you have perfect numbers, perfect points, right? And we said that this point right here is perfect because we can see that it fits perfectly at -4, 6. We can see it. We also said that the y-intercept point is perfect because you can see that this is perfectly on negative or 0, -4. We can see it, so it's easy to see that. However, what if I wanted to know another point that's not perfect on this graph? So let's say I want to know where the graph is at this point right here. Can I know that just by looking at it?
No.
It's kind of in the middle, right? So like, I don't know, I can kind of estimate, but that's not going to give me a perfect answer. It's not going to give me an accurate answer. So my equation can come in handy because just like all of the equations that we've talked about with functions, I have variables here, and those variables are my input and my output. So which of those two variables is the input? Is it the x or the y?
The X.
The X.
Mm-hmm. The x is my input, and the y is my output. So my equation can be used to figure out an input that I don't know about. So like I was trying to say, I don't know, I want to know where the line is when x is -3. Or actually, let me use a better point. Let me do, let's do at 2. So I want to see where's the graph when x equals 2. So for example, if I had a nice table going, because remember, functions can be on a graph, can be on a table, they can be an equation. And I already know I have -4, 6, and I already know I have 0, -4, but I want to know what happens at the 2. I want to know where the graph is when the input is 2. That's where my equation comes in. So what I can do is I can take my equation, and what do I know I can do with equations? What can I do to my input?
Plug in 2.
Yeah, I could plug in 2 because I'm curious. I just want to know what happens at the 2. So I can plug in 2 and figure out what my output is going to be. So here I would multiply first. So -5 times 2 is -10, and then -10 divided by 2 is -5. So I have -5 minus 4. And what's -5 minus 4?
-9.
Mm-hmm. -9. So I know that when my input is 2, my output is -9. So this point right over here on the 2, that's -2, -9. So that's why equations are so, so, so important, because they can help us out when our visuals, when our graphs don't. Okay, so if you're wondering, why am I doing this? Why am I writing equations? That's why, because they're super, super important. Actually, I don't want to delete that. They're super, super important in algebra. They're very important for us to understand things that we can't see. So that was kind of a lot. Let's do a few more examples. This will become a lot easier the more examples we do. So again, I want to write an equation. I want to write a slope-intercept equation. So I'm going to write it, the general form up here, y equals mx plus b. Okay. And so what are the two things I need to know in order to write that equation?
Your y-intercept.
The y-intercept
and your slope.
and the slope. I need to know those two things so that I can put them into the equation. So this comes back this is very similar to the first problem we did during the bell ringer. I have this graph, it's labeled, I need to figure out the slope and I need to figure out the y-intercept. Now, before I begin to figure out the slope, I need to check if I have perfect points. So are these perfect, these points that they labeled?
Yes.
Yeah, we got lucky. These are actually perfect points. So we don't really need to find any more. We can use the ones that they give us. So I want you guys now to take 3 minutes to calculate the slope and figure out where's the y-intercept. 3 minutes, calculate the slope and figure out where is the y-intercept. And for the slope, you can use whichever strategy you want. About 1 more minute remaining. Send me your answers in the chat when you have them. I've only gotten 1 answer so far. What's the slope? Where is the y-intercept? All right, that is time. All right, I only got 2 answers in the chat, so I just need to do a little check here. Okay, 3 answers in the chat. I need to do a little check here. Give me in the reaction buttons a thumbs up, thumbs down, or if you're somewhere in the middle, do the clapping button. So again, tell me how you're feeling. Thumbs up, thumbs down, or if you're somewhere in the middle, do the clap. Okay, I see mostly claps. Mostly claps and thumbs ups. Okay, so I don't see any thumbs down, so that's a good sign. But I do see that I seem to need to explain things a little bit further. So we're just gonna, this is all we're doing today. So I'm just gonna do it over and over and over again till it makes sense.
Miss, it's because I like the rise and run more better.
You like rise run better than the equation?
Yes.
So do it. Did I tell you which one you have to do?
Oh, Miss, I thought we had to do only that.
No, I said it at the beginning. I said the same thing. I said you can choose whichever one you want. You can use whichever strategy you prefer. So I'm going to show you both, but you get to choose your journey. You can do whichever one you want. I'm going to start by using the formula because I know more people tend to like the formula. But again, you can do whichever one you want. So the formula is y2 minus y1, x2 minus x1. Okay. If I put these in a table, it would be 0, comma 5400, and 4, comma 2400. So what's my y2 minus y1?
2,400 minus 4,400. I mean 5,400.
Good. 2,400 minus 5,400. And then x2 minus x1?
4 minus 0.
Yeah, 4 minus 0. Now we do the math. What's 2,400 minus 5,400?
Negative 3,000.
Negative 3,000. 4 minus 0 is 4. And now we divide. What's negative 3,000 minus, or divided by 4?
Negative 750.
Negative 750. What are my units?
Height per minute.
Height, and then what are they measuring the height with?
Feet per minute.
Feet per minute. Okay. Questions on how I got that answer using the formula. And yes, Ascanio, exactly. This is decreasing. This is a decreasing negative slope. Questions on how I did that using the formula? Okay. So now I'm going to go ahead and I'm going to do the same thing, but this time I'm going to do rise over run because some of you prefer that, and that's fine. We are all different types of learners. So that's my rise, and this is my run. And now I need to count, but I need to be careful because the units matter. I'm not just counting boxes, I'm counting the units. And what are the units going by? How much is each box worth?
$60.
600.
600.
Yeah, 600. So if I'm counting by 600s, how many units total am I going down? Good, Ascanio. 3,000 units, and I'm going down, so it's negative 3,000 units. Okay, so that's why this strategy works. This strategy might seem easier, but you really have to make sure you're counting the units, not just how many boxes there are. Now, going across, again, how many units is each box worth going across?
4.
4.
I mean 1. So
Right. So each one is 1, so total is 4. All right. So again, rise over run, we get the same answer. The rise is negative 3,000. The run is 4. And in both cases, we get negative 750 feet per minute. All right. So Miriam, like I was saying before, you can choose whichever one of these two strategies you prefer. I'm not telling you which one to use. If you like the formula better, use the formula. If you like rise over run better, use rise over run. Totally up to you, as long as you're doing it correctly. Make sense?
yes.
Sweet. All right. So that's the slope. What about my y-intercept? Let me delete all this stuff so we can see it clearly. Where's my y-intercept?
5,400.
5,400. All you do is look at where your line is on the y-axis, and here it's at 5,400, so that's my y-intercept. So I have my m and I have my b. But I'm not done because the question is telling me to write the equation. So now
So
I'm
wait,
just going to put it.
The B is your x. I mean, the B is your y-intercept.
Yes, B stands for y-intercept. Yes.
Oh, okay.
Mm-hmm. Okay, so now that I have all the information I need, I can write my equation. All I'm doing is filling in the blanks for the M and filling in the blanks for the B. So can anyone tell me what the final equation will be?
Negative 750 plus 5,400.
Very, very close. You just forgot one tiny little thing.
X
X.
plus B.
Yeah.
I mean, plus that.
So don't forget there's an X here
Oh, because feet per minute.
because you have to include the two variables.
Okay.
So there you go. Y equals negative 750x plus 5,400. That's the equation, and that's it. That's all I need to do. I'm not solving for anything. I'm not doing any more math. As long as you have the M and the B, you can put them in your equation and you're done. Questions? Any questions? Any question goes, because right now I know we're all learning. A lot of you guys are still a little bit iffy on this, so I want to make sure that I am as clear as I can possibly be. Going once, going twice. Okay, so now it's your turn. This time, all on you. You need to write the equation for both of these graphs. But since I'm asking for the equation, what does that mean you have to find first?
The slope and the y-intercept.
The slope and the y-intercept. You have two different types of graphs. One of them is a real world scenario, and the other one is just a regular old graph. So we got to get used to doing both ways. Use, again, whichever strategy you prefer, use it. Do whatever makes you happy, as long as you're doing it correctly. I'm going to start with only 5 minutes, but I feel like you probably will need a little bit more. So 5 minutes on the clock now, and then I'll see if you need any more. Go ahead and begin. Okay, about a minute and a half remaining. Remember, you can send me answers if you have them already. Okay, there's about 5 more seconds, but give me a thumbs up reaction if you would like a little more time. Thumbs up if you need a little bit more time. Okay, I'll give you guys 2 more minutes. 2 more minutes, but then I'm gonna go over it. So if you don't finish, that's okay. Okay, that's it. All right. Before I begin, guys, I've had some conversations with a few of you guys in the chat, not just one person, it's been like 4 or 5 people saying that they're having trouble with slope, so calculating the slope. Now, today's Wednesday, right? We did slope on Monday, we did slope on Tuesday, and we're doing slope again today. This is the 3rd day I'm going over how to do slope. So if you were absent, or if you walked away from that class not understanding anything, I'm not going to go back and reteach something that I already taught. So it is your responsibility when you are absent to watch the videos that I'm always guys, every single day I put that video up on YouTube. Every single day. I haven't missed a single one. but that's your responsibility, not mine. Okay, so if you're lost right now because you weren't here or because you weren't paying attention, I can't really help you because I already taught this. Like I'm already wasting time as it is. So you got to get into the habit of it, guys. If you miss class, it is your responsibility to watch the videos. All right, so for number A, letter A, rise, I could do rise over run, but for now I'm going to do the equation because I know most of you like the equation better. Okay, my 2 points are 1,000, 310, and 35,000. 3,500, 460. Plugging it into the equation, I have 460 minus 310 over 3,500 minus 1,000. When I subtract 460 minus 310, what do I get?
Miss, now I know why I got it wrong. It's because I switched the X and X1, I mean, those thingies.
Yeah, okay, so you got to make sure you put them in that order, yeah. All right, but either way, what do you get for when you subtract? 460 minus 130.
150.
150, good. 3,500 minus 1,000.
2,500.
2,500. And let's divide. What do I get when I divide? 150 divided by 2,500.
Zero 0.06.
Good, 0.06. That's my M. That's all I got. That's it. Now I do my B. For B, all I do is look at the graph. Where is the y-intercept on this graph?
250.
250. You're just looking at the first point, 0, 250. And now I have everything I need to write my equation. I have my M, I have my B. Who would like to say the equation nice and loud?
Y equals 0.06x plus 250.
Mm-hmm. That's it. Once you find, the hard part is figuring out the slope. That's always going to be the hardest part. Once you have the slope and the y-intercept, you're just playing a game of fill in the blanks. You're just filling in something for M and something for B. Questions on number or letter A? All right. Same thing goes for letter B. Okay, we're still doing the same exact thing. It's just that here they didn't label points for us, so we have to label them ourselves. So can somebody give me 2 possible points that I can use when I'm calculating the slope?
3, -2.
3, -2. That's over here. Oh, I see what you mean. That's not 3. 3, -2. Well, unfortunately, this is not a perfect point. It kind of is.
Oh, yeah.
Because you can kind of tell that it's at the 3, but it's kind of in the middle, so we can't know for sure. So instead, what can I do?
0, -4.
So I have 0, -4. And let's pick a different point that's perfect. Anywhere on here. Somebody else. Ilse's been talking a lot, and I appreciate it, but I do want to hear from other people.
-6, -8.
Beautiful. -6, -8, right here. So those are 2 points I can use. And then there's also, yeah, Ascanio said it in the chat, 6, 0. Here's another one. So there's a lot of different possibilities, and you can choose any of those, any 2 points that you want. It's going to work no matter which ones you choose. Okay, so up to you. But for now, I'm going to say I feel like using -6 comma -8 and 6 comma 0. Okay, so I'm going to use those 2 points. Should I do, because in the last problem I did the formula, would anyone like me to do rise over run? Anyone want me to show how to do rise over run? You can give me a thumbs up.
I was able to like learn the MX for A, but I didn't know how you got 250.
For problem A, woo, we moved past that a long time ago. You should have asked when I was doing it, because right now we're on problem B.
All right.
In problem B, okay, so nobody wants me to do rise over run? You all want me to do the formula instead?
Yeah, the formula.
Formula? Okay, we got a class full of mathematicians here. No one's visual. Okay, so I'm going to use the formula. So my formula is m equals y2 minus y1 over x2 minus x1. These are the points that I chose to use. I could choose any 2 points, but I decided on these. What's my y2?
0.
0. So I have 0 minus -8 over 6 minus -6. All those double negatives, what do they turn into?
Addition.
Addition. So I have 0 plus 8 over 6 plus 6. What's 0 plus 8?
8.
6 plus 6?
12.
12. So I have 8 over 12. Can I simplify that?
Yes.
What can I simplify that to? Let's keep it as a fraction. And what can I simplify it to?
2 over 3.
2 over 3. Very good. If you divide the top and the bottom by 4, you get 2 over 3. There's my slope. M equals 2 over 3. Questions on how I got 2 over 3? Make them quick because I got to move on. We're running low on time. Okay, cool. I'm going to erase all this work because now I want to clear my page and make it look neat so that I can see what I'm looking for. Because now I'm looking for the y-intercept. So where is this pink line crossing the y-axis?
-4.
Good, -4 right here. 0, comma, -4. So b equals -4. So I have my m, I have my b. Now I can write my equation. Who can write the equation for me?
Y equals 2 over 3 x plus -4.
Perfect. And since I'm doing plus -4, I can clean that up a little bit. And remember, when you add a negative, it's the same thing as just subtracting. So rather than writing plus -4, what can I write?
-4.
Just -4, exactly. So y equals 2/3 x minus 4. That's the equation. That's it. So it's always, anytime it asks you to figure out what is the equation, it's always going to be 3 steps. Find the slope, find the y-intercept, write the equation. Questions? Okay. Your homework, by the way, we still have a couple more problems, but on your homework assignment that's due tomorrow at midnight, you have a lot of problems that are asking you what is the slope. So that's the most important thing to just make sure you understand how to do. How do you find the slope? Between any 2, you pick any 2 points, and you can either use the formula or rise over run. I'm going to skip these. We'll do that tomorrow. All right. So on a test, however, usually on a test, you're going to have two different types of questions. Either it asks you to write the equation, just like we've been doing, or it's going to give you an equation and you have to find the correct graph. So this is a very good example of what this would look like on a test. So that's why I wanted to show you guys this question. So this one is saying, which of the following is the graph of y equals negative 3/2 x plus 6. So this is the equation of the line, and we're trying to see which of these four options matches that equation. So in order to figure out our answer, we need to figure out what do we know about this line based on the equation.
You're asking?
Yeah, I'm asking you.
Oh, the slope and the y-intercept?
Good. So I know my slope, and what's my slope?
Negative 3/2.
Mm-hmm. And I know the y-intercept. What's the y-intercept?
6.
6.
6.
So what I can do is I can play a little game of matching, okay? I need to find which one has the correct slope and the correct y-intercept. So which of these two things is easier to see, the slope or the y-intercept?
Y-intercept.
Yeah, so I always say start by looking at the y-intercepts and see if you can eliminate any choices. So I want everyone to take a look at each of those four graphs and check to see where the y-intercept is. It should be at the 6. So if that's not the case, which graphs can I get rid of?
1 and 4.
4.
Okay, yeah, because 4 and 1, where is the y-intercept in answer choice 4?
It's on 4.
It's on the 4, right here, 0, 4. Where's the y-intercept in answer choice 1?
4.
It's also at the 4. So I know that's wrong. However, in answer choice 2, it's at the 6. And in answer choice 3, it's also at the 6. So those match. But now we need to figure out which of those two answer choices has the correct slope. So if my slope is negative 3/2, try and see if you can figure out which one is correct.
I think it's 2.
You think it's 2? Why do you think it's 2?
Because if you look at the point, it looks close to the 3, and I don't know. It
Well,
just looks like it's
does-
like close.
yeah, but does slope tell us a point?
No.
What does slope
Oh,
tell
wait.
us? Slope represents what? The what?
Forgot.
What's another word for slope? Another word for slope is rate of change. So slope
I
isn't
said
telling us,
it, but I was still on mute.
so slope doesn't tell us a point on the graph, it tells us the rate of change. And in this case, my slope is negative. And that's a very important thing to notice, because if you know the slope is negative, you already know something very important about that graph. Can anyone tell me which answer choice it might be based on that information?
3.
Based on the fact that it's negative?
Oh, 2.
Why is it 2?
Because when you look at the line or the slope, I guess
Mhm.
it's facing the direction. You know, the one where you showed us of the man, and then the
Yeah,
average is negative.
yeah. This is where you would call your friend. You got to call your friend the slope man. And this is why I genuinely recommend that you write this down in your notebooks. It looks a little silly, but it's actually really, really helpful. because
Also, Miss-
Slope Man helps you remember which type of slope is positive and which type of slope is negative. Because check out his eyebrows. His eyebrows are facing a specific direction. This eyebrow is a negative slope, and the other eyebrow, that's a positive slope. So which of those graphs, graph 2 or graph 3, is facing the right direction of a negative slope?
the 2.
3.
3.
No.
Negative slope. Look at this
Oh,
negative.
two. Yeah,
Yeah.
because -3, number 3 is like from the top. This is going down.
Okay, so graph number 2, that's a negative slope. This is going down. I know there's arrows on both sides. Trust me, I know that. It's not about the arrows, it's about the direction of the graph. The graph is a negative graph. Whereas answer choice 3, we call this a positive graph because it's increasing, it's going up. Even though the arrows point both ways, I know. That's not what I'm looking at. It's about the direction. So one is negative, one is positive, and you have to know which one is which, because with a question like this, that's going to tell you the right answer. All right, since my rate of change, since my slope is negative, the answer has to be graph number 2, because graph number 2 has a negative slope with a y-intercept at 6.
And so we didn't even have to do the work.
You didn't really have to find the slope, no. Because just by knowing it's negative, I was able to eliminate answer choice 3. A lot of times on questions like this on a test, you barely have to do work. You really just have to play process of elimination, cross things out until you find the right one.
Oh, I think I know why number 3 is in it, because when you said it like starts from the bottom, because you know how like because it has like negative on that like one side, and then you went up. Yeah, that's why, because you went from a negative to a positive, and then on graph 2 you went from a positive to a negative.
Yes, that's exactly why. I also like to think about it like if you have a man at the edge of your graph, this man is going to walk up the hill. But if you have a man at the edge of this graph, he's going to be walking down the hill. Positive versus negative. Let's do one more before time's up. We have 5 more minutes. All right, for this one, the equation is not in the right order. So I'm going to very quickly put it in the right order. We'll learn how to do that tomorrow.
Starting on the 3rd floor.
Oh, they're gonna make you guys leave. I don't think we'll have time for this. But that's okay, we'll do it tomorrow. So for now, all I have for you is that you have homework due on Thursday at midnight. Do not forget. However, and this is very, very important, grades are due tomorrow at noon. So if you want this homework assignment to count for your grade, you have to do it by tonight at midnight. One more time, if you want this homework to count towards your grade, you have to do it by tonight at midnight.
Miss, does it go for research?
This one will be going in for research, yes.
Okay.
Wait, for both for
Just
both
research.
for research, or one for algebra, one for research?
Oh, you're right, because there's 2 of them. One for each.
Oh,
One for
okay.
each.
Okay.
I was
Okay.
wondering like which one's gonna be for which.
I always randomize it, so you never know which one's going to be for which.
I hope the 75 one goes for algebra.
You could always do it again to get a better grade.
That's what I'm trying to do.
All right, so do it tonight if you want it to count. Otherwise, it'll be due tomorrow at midnight. Have a good day. I'll see you guys
Miss.
tomorrow.
Bye, Miss.
See you
Bye,
Have a
tomorrow.
nice day.
Have a nice day. Bye.
Bye, Miss.
Bye.